Alright, we're going to be talking about other angles that can be found in circles. Now, in our last video we talked about inscribed angles, which were made by two chords. Some of the angles that we talk about are going to be made by tangents and chords, or secants and tangents, and etc. So we're going to be looking at things that are not just two chords like your typical inscribed angle, but those that are made by secants and tangents as well. Alright, so in this first picture, what you'll see here is that this line here is a tangent because it touches the circle once at point A. I also have a chord AB here. Now, the chord and the tangent meet and make two angles, angle 1 and angle 2. If you'll take a look here at angle 2, this right here is considered to be angle 2. Notice that the vertex of the angle is still on the circle, so it actually follows the same rule as inscribed angles. It's going to be 1/2 of the arc it intercepts, so arc ACB. So whatever ACB is, let's say 200, then angle 2 will be half of that, 100. Now if you take a look over here, angle 1, this is angle 1. And its vertex sits on the circle, and the intercepted arc that it makes is arc AB. So if arc AB, we said the other one was 200, so we would say this is 160, and then half of that would make this 80. Okay? So because the vertex of each angle still sits on the circle, it still follows the rules of 1/2 of the intercepted arc. Alright, so here we have KL, and KL is tangent to the circle. It's our job to find the measure of angle KLM. Well, I know that KLM is 4x, and the arc it intercepts, LJM, is 12x minus 100. So I know the arc is going to be, if I multiply it by 1/2, it's going to be equal to the angle. So I replace KLM with 4x, and I'm replacing measure of arc MJL with 12x minus 100. But because the angle and the arc aren't equal to each other, it's 1/2. So you're going to make sure you put your 1/2 there. Now, what they want you to do is they want you to multiply by 2 on both sides, because what that's going to happen is 1/2 times 2 is 1, and I'll be left with 12x minus 100. So then 4x times 2 is 8x. You could have also distributed the 1/2 in. It's up to you on your preference. Now, what they want you to do is they actually want you, and there's two steps happening here. They want you to subtract 8x from both sides and also add 100 to both sides. So they're doing two steps in one here. But 8x minus 8x goes away. I'm left with 100. 12x minus 8x is 4x. And then 100 plus a negative 100, those are 0, so I can get rid of those. Then by dividing by 4, 100 divided by 4 is 25. So I have found that x equals 25. Now here's the thing, I'm not looking for x, I'm looking for the measurement of the angle. The measure of the angle is 4 x's, so 4 times 25, because that's what we found x to be, 25. So the angle must be 100 degrees, and then the arc KJM must be 200. Okay? Alright, why don't you pause and give this one a try. What you're looking for here is the angle QRS. So pause now and give it a shot. Alright, I know that 5x minus 10 is going to be 1/2 of its intercepted arc, 8x plus 32. To show you the other way, how you can distribute in, I'm going to distribute the 1/2 to both sides. So 5x minus 10 equals 1/2 times 8x is 4x, 1/2 times 32 is 16. I'm going to subtract 4x from both sides. So I get x minus 10 equals 16. I want to add 10 to both sides. X equals 26. So that's not my final answer, because I need to plug in 26 in at 5x minus 10 in order to get the angle measure. So 5 times 26 minus 10, and that would be in my calculator 120 degrees. So if the angle is 120, we know that the arc SPR is 240 twice 120. Alright, so here we have two chords intersecting inside the circle. Now notice, this does not have to be the center of the circle. These are not diameters. These are chords anywhere in the circle. Now, angle 1 is going to be the measure of arc DC plus arc AB and then divided by 2. What you're doing is you're finding the average of the two arcs. Basically what's happening here is I know angle 1 and this angle here must be the same because they are vertical angles. So in order for them to be the same, we find the average of the two intercepted arcs. Now, the same can be said for angle 2. Here's angle 2, and this angle right here, they must be the same measure because they're vertical angles. So to find the measure of angle 2, I would take the two intercepted arcs, BC and AD, and add them together and then divide by 2, finding the average of the two intercepted arcs. Alright, so we have a few more. Let's go ahead and slide this up so we can see better. Alright, in the first one up at the top right, I have a tangent line and a secant. So this is tangent and secant. So what I'm going to do, notice that the angle is on the outside in all three of these cases. What that means is we're actually going to subtract. So in the previous theorem, they crossed in the middle like a plus sign, so we added them. Now that it's outside, we're going to subtract and then divide by 2. So you would take the big arc, BC, and subtract AC and divide by 2. Notice that when I have the tangent two tangents outside, so these are two tangents, I would take the big arc, PQR, and subtract from the little arc, PR, and divide by 2. And the same applies for the two secants. You take the big arc, XY, minus WZ, the little arc, and divide by 2. So this is 2 secants. Alright, so that was 4 theorems. There's a lot going on. Let's practice finding. Alright, so in this problem, we have two chords crossing inside of the circle. Because they're crossing, I automatically know that we're going to add these two. So to find the angle, I must find the average of the two intercepted arcs. So that would be arc FH, yes, FH, and GJ. You could have also said JG, it doesn't matter. So, the measure of angle FH is 136, and the measure of GJ is 150. So when I add these and then divide by 2, or multiplying by 1/2 is the same thing, I get 143 degrees for angle X. Oops. There we go, much better. Alright, now in the case where the vertex appears outside of the circle, we know that we need to subtract. So in the first problem, I know the angle is 58 degrees. So what I need to do is I need to do the big arc minus the little arc equals 58 degrees. So the angle is 58 degrees, 1/2 of the big arc, which is X, minus 64. Okay, now it wants us to multiply each side by 2. So what you're going to do is 58 times 2 is 116. So then I'm left with, since 1/2 times 2 is 1, I'm left with X minus 64. By adding 64 to both sides, 116 plus 64 is 180. And that's the measure of the arc LMN, 180 degrees. And what that also means is that if I were to connect point L to point N, I can actually create a diameter because the arc LMN is 180 or a semicircle. So from L to N would cut the circle in half, and this would be my center. Alright, so scrolling down a little bit so that we can see part B. We'll have to go kind of up and down here to make sure we got everything. Now angle X is what we're looking for here. So it's big arc minus little arc divided by 2. So 68 minus 24, and then multiplied by 1/2 or divided by 2. Alright, so if I subtract 68 and 24, I get 44 degrees, and then multiplying by 1/2 gives me 22 degrees for the angle in this picture. So up here, this angle right here is 22 degrees. Okay? Alright, what I'd like for you to do is pause and try these two. Make sure that you go back and look at the theorems and see which one applies. Are you going to be adding and then dividing by 2, or are you going to be subtracting and then dividing by 2? So try these two problems on your own right now. Alright, since these angles have a vertex in the interior of the circle, inside the circle, we're going to add. So x will be equal to 1/2 of 91 plus 55. And that would be 73 degrees. There we go. Now in this problem, it's actually a little bit trickier. Notice that the arcs that angle x makes are here and here, and we don't have that information. However, what we can do is find the missing angle here, and then because these two angles, x and y, are a linear pair, they must add to 180 degrees. So angle y is going to be 1/2 of 106 plus 86. Okay, which is 96 degrees. So if this angle right here is 96 degrees, then I know that angle x must be 180 minus 96, because they are a linear pair. So angle x will be equal to 84 degrees. Alright, let's go ahead and try 4 and 5 as a checkpoint question. You give it a shot, and then pause. When you're done, unpause. Now on problem number 4, you'll notice that we've only been given one number, 110 degrees. However, when I have two tangents, I'm using the entire circle. So the remaining arc here, BCD, must be 360 minus the 110 degrees. So that would be 250 degrees. Now, since angle A, or x degrees, is on the outside, we will subtract. So x will be equal to 1/2 of 250 minus 110. Typing that in my calculator, I get x equals 70 degrees. Here, the angle is again on the outside, so we will subtract. This time, the angle is 72, so the angle is equal to 1/2 of the big arc minus the little arc. Okay, so that's how you would appropriately set this problem up. Okay, now I would multiply both sides by 2. 72 times 2 is 144. 1/2 times 2 is 1, so I'm left with 210 minus x. By subtracting 210 from both sides, I get negative 66 equals negative x. Dividing by negative 1, I get 66 equals x as my answer. Alright, that's it for our other angles for today. I will talk to you guys later.